Hello, fourth graders. This is a review of the practice problems for Lesson 15, Comparing Fractions, the learning target for this. I can use common numbers to compare fractions. In the last video, I left you with 3 practice problems with a lesson going over different ways to use the numerator and denominator to be able to compare fractions. So the first one is 1/4 and 3/16. You actually have 2 ways to look at this one. You can use common numerators or common denominators. The first thing I'm going to do here is look at common numerators. So if I look at this and I'm thinking equivalent fractions here, and I want to get the numerators to be the same, it's very easy to take this 1 and turn it into 3 by using my equivalent fraction sentence. So if I'm doing equivalent fractions, 1 times 3 is 3. Now I'm going to multiply my denominator by 3. 4 times 3 is 12. So essentially what I'm comparing here is 3/12 and 3/16. Going back to the lesson, when we think about this, 12ths are bigger than 16ths. So if I have 3 pieces that are bigger than 3 pieces that are smaller, this fraction will have a greater value. So 1/4 is greater than 3/16. Another way I can do this is looking at common denominators. So if I'm looking at 4 and 16, I'm able to change fourths into 16ths because 16 is a multiple of 4. 4, 8, 12, 16. Or another way I can say it is that 4 is a factor of 16. 16 can be divided by 4 and have a even answer. So I know that 4 times 4 is 16, so I'm going to make common denominators here so I'm comparing units that are the same size. Four times 4 is 16. 1 times 4 is 4. So now what I'm doing here is I'm comparing 16ths to 16ths. This would be your classic comparing apples to apples and oranges to oranges. I know that 4/16 is larger than 3/16. Okay, the sizes are the same. There's one more piece here. So 1/4 is greater than 4/16. All right, practice problem number 2 was 2/3 and 7/9. Now, comparing this one, I'm not going to be able to do common numerators. The reason for that is I can't turn 2 into 7 by multiplying by a whole number. 2 times 3 is 6. 2 times 4 is 8. Nothing times 2 makes 7. So what I'm really going to focus on here is using common denominators to prove that one of these fractions is greater than the other. So one thing here is 3 fits into 9. So 9 is a multiple of 3. 3, 6, 9. Third multiple. Another way to say it is 3 is a factor of 9. So what I can do is I can manipulate this fraction and I can turn it into ninths using an equivalent fraction sentence. 3 times 3 is 9. 2 times 3 is 6. 2/3 is equivalent to 6/9. Okay? So this tells me here is when I'm comparing these fractions, 6/9 is less than 7/9, which means 2/3 is less than 7/9. Okay? So using the equivalent fractions idea, I can take this and go back to here and complete my fraction sentence. Now, one other way to prove this, and I think I talked about this in the lesson, is to multiply the denominators and create equivalent fractions for both fractions in this problem where I am multiplying my denominators. So 3 times 9 is 27. This way is a little more work, but it works. Okay, so 3 times 9 is 27. So this 3 was multiplied by 9. That means this 2 will be multiplied by 9 to make my equivalent fraction. 2 times 9 is 18. Okay, now we'll move over here. This 9 was multiplied by 3. So this 7 will be multiplied by 3. Now what we have here are two fractions that are equivalent to their beginning fractions in 27ths, which is a little bigger than ninths. And we did double the work, but it is still a strategy that works. When you multiply the denominators, you're going to create common denominators. You'll see this as a strategy moving forward when one of the denominators doesn't fit into the larger denominator. For example, if we had fifths and sevenths, a 5 would not fit in a 7 evenly, and we would have to go to a multiplication strategy, probably using 35ths at that point. So this just further proves 2/3 is less than 7/9 because 18/27 is less than 21/27. Okay? All right, the last one was 7/6 and 13/12. Right off the bat, one thing I want to point out about this is these are improper fractions. They are greater than 1 whole. What's unique about each of these is they are 1 part greater than 1 whole. If I were to decompose these using a number bond, I could break 7/6 down into 1 and 1/6. 7 or 6/6, which is 1. Okay, I could even show you. Right, 6/6 plus 1/6 is 7/6. And I can rewrite this as 1 and 1/6. Okay. Over here, we can have 12/12 plus 1/12, which is 1 and 1/12. So essentially what we're going to compare here is the fraction part of our mixed number. 1 and 1/6, 1 and 1/12. Well, I can cross off the 1 wholes because they're equal. Okay. And now what I'm really comparing here is a 6 and a 12. And this problem, by doing it this way and bringing it down and decomposing it, lets me use the strategy of common numerators. So my numerators being the same here, I know that 6 is a much larger piece than a 12th. It actually takes 2 12ths to make a 6th. So just by looking at that, I know that 7/6 is going to be greater than 13 12ths. There we go. All right. Now, this is a strategy that works. Some of you might have seen this right away, where you're like, okay, these are 6. This is 1 part more than a whole of 6, and this is 1 part more than a whole of 12ths. I know that 6 are bigger than 12ths, so that must mean this one is bigger. Some of you with your fraction background knowledge, you'll see that right away. It'll click right away. Others, you might have to go through these algorithms to come up with a solution. Another way to prove this is to use common denominators. So this is a problem where the smaller denominator 6 fits into the 12ths. 6 is a factor of 12. 12 is a multiple of 6. It's the second multiple, 6, 12, 18, and so on. So what I can do is I can change this fraction here into 12ths using equivalent fraction sentence. 6 times 2 is 12. 7 times 2 is 14. 14 12ths is bigger than 13 12ths. It's 1 12th greater than. So Hopefully going through all these strategies for these three problems and the different ways to attack it really open your eyes to just working with numerators and denominators and moving out of what I like to call robot mode, where you just feel like you have to always do the algorithm. As you grow with your knowledge in fractions, you'll see that you'll begin to understand that the denominators really show you the size of the pieces, and that you don't always have to go into a real deep dive, getting out pencil and paper and showing your work. As you continue to work through this, your knowledge will just continue to evolve, and you'll be able to do more mental math as you work towards hitting your learning target. I can use common numbers to compare fractions.